everyone, welcome back to the Life Changes Academy. This is the Intermediate Machine Learning course part 3. So in this session we are going to learn about the regression algorithms and how the regression algorithms works and its futures and so on, right? So in the previous video and all we will be learn about classification algorithms where machine learning predicts categories like spam or not a spam, cat or dog, pass or fail and etc, right? But if we don't want a category, we want the exact number means, for example, what will be the price of the house? How much revenue will the company earn next month? Or else what will tomorrow's temperature be? What will be the resale value of this car after the 5 years? Notice something here. All these answers are numbers, right? And that exactly what that regression algorithms comes into this picture. Okay, so in this today's session we are going to understand the regression in the easiest way as possible. Okay, so without any we will be start the session. First we are going to learn what is regression. Before we learn the algorithm, let's first understand what regression actually means. So guys, just imagine you're planning to build a house, okay, or else planning to buy a house. You find a beautiful house in online, but the price isn't mentioned in the particular app. Okay, so now naturally you start thinking that will it be 50 lakhs or else 70 lakhs or else it may be 1 crore. Likewise, you will be thinking some prices. Okay, depending on your knowledge you will be thinking, you are trying to predict a numerical value there. Okay, so that's the concept. That one is the regression. Okay, so regression in the machine learning is nothing but it's like a technique that is used to predict the continuous numerical values. Okay, so unlike the classifications which predicts categories, regression predicts the numbers. Okay, classification is just predict the categories and then regression is just to predict the numbers, that means numerical values. Okay, a simple way to remember it is this: classification answers which category, and then regression will answer how much or what value. Okay, that is the biggest difference between the regression as well as the classifications. Okay, and then we are going to see an interesting concept. That one is a linear regression algorithm. Okay, now let's start with it. This one is the simplest regression algorithm. Okay, that one is a linear regression. This is usually the first regression algorithm every machine learning beginners learns. Okay, let's first understand with a simple example. Okay, so you guys all imagine in a class there are two students. Okay, so the student A and then student B. Okay, the first student, I mean the student A, the student A studies for 2 hours only and they scores 50% of marks. Okay, and then student B, the second person, will study for 4 hours. Okay, it will be double. And then the person student B score 70% of marks in the exam. And then another one student, that one is the student C, that person studies for 6 hours in a day. And the student C scores about 90% of marks. Okay, can you see the pattern? I mean, as study hour increases, marks also increases. That concept is the understanding the pattern. Okay, so the linear regression learns this pattern. I mean, learns this relationship. Okay, now suppose a new student studies for 5 hours. The model says, based on the previous pattern, I mean 2 hours means they will be scoring 50%, 4 hour means 70%, 6 hour means 90%, and then a 5 hour means they will be based on the previous pattern only. It will be analyzed that it will be around 80% of marks. Okay, see what happened. The model didn't memorize the answers. It learned the relationship between study hours and marks. Okay, and then predicted a new value. That's how the linear regression will be working here. Okay, so next that one is the classic example. Study hour increases means the exam marks also increases. Okay, so the linear regression that doesn't memorize anything. It will be learning from the pattern, learning from the data. Okay, it will learn the relationship between the study hours as well as the marks. Okay, so that's why the linear regression, because the relationship follows a straight line. Okay, and then I'm saying some of the real-time examples in the linear regression. So, where do we actually use this? Almost everywhere, guys. Why? Because means the real estate companies use it to predict house prices, and then retail companies use it to forecast the sales, and then business use it to estimate the future demand. Even weather departments are use this similar technique to predict the temperature trends. Okay, so whenever the output is a number, regression becomes very useful in the particular platform. Okay, whenever the answer is the category, which you will be using a classical classification algorithm. Whenever it will be a number, means linear regression. Okay, keep it in your mind like that. Okay. So next algorithm, that will be a multiple linear regression. First we are seeing about linear regression. Now we are going to see about multiple linear regression. Okay. Earlier, now let's make the problem a little more realistic here. Okay, so in the earlier section and all, we predicted house prices using only one factor, maybe just the size of the house, right? But in the real life, does the house price depends only on the size? Of course not. Why? Because means imagine two houses. Okay, both are 1500 square feet. One is in the city center, another one is far outside from the city. Okay, will both have the same price? Definitely not. Why? Because means many factors affect the price, like area, location, number of bedrooms, parking space, nearby schools, hospitals, shopping malls. So these are the categories that will differentiate the price between the houses. Okay, so multiple linear regression, it looks at these factors together before it will predicting the final price. Okay, think of it like this: instead of asking one person for advice, you are listening to many people before making a particular decision. That's exactly what multiple regression also does. Okay, so depending on the bedrooms, depending on the area, location, hospital, schools, the cost of the particular house will be higher. So the outside the city means there is no hospital, no nearby schools, no nearby office and all. So the price of the particular house will be comparatively low. Okay, so this is the multiple linear regression, and then we are going to see polynomial regression. Now here's something interesting. Okay, not every relationship in the real world is a straight line, right? Let's take a simple example. Imagine, guys, you are riding a bike. Okay, at first, as you increase the speed, what happens? The fuel consumption increases slowly, right? After some point, fuel consumption increases much faster, right? There is no longer a straight line relationship here. It is like a curved relationship. So the linear regression struggles here. So that only we are using a polynomial regression in this case. Okay, so instead of fitting in a straight line, polynomial regression fits a curve that follows the actual data. Okay, another great example is temperature. During the year, temperature does not increase in a straight line, right? It goes up during summer, comes down during winter, and changes continuously, right? So that only the polynomial regression can model these curved patterns much better. Okay, see the difference in that the fuel consumption is 20, 22, 28, 30. Here 30, 35. Likewise only it will be changing, right? 32, 50, 55. Likewise only it will be changing. So the consumption of the fuel will be changes manually, right? So that the curve should not be in a straight line. It will be in a curved straight. So that we are using this polynomial regression here. Okay. So next we are going to see another one concept. That one is predicting sales and prices. Okay. So one important thing to know that regression is one of the most widely used tools. Okay. So suppose for example suppose I keep drawing more and more curves just to match every single data point, means eventually the model memorizes the training data instead of learning the real pattern, right? So the problem is called the overfitting. Overfitting also a concept. Okay, that is the model doesn't memorize anything. Instead, it will be learning from the original data. So it will be having more data in it. So the line should be not in a straight line. It will be a curved surface. So that kind of appearance should be emphasized inside the overfitting concept. Okay, a good machine learning model should learn the pattern, not memorize the pattern. Okay, so it will be widely used in real estate, sales forecasting, product demand, and automotive services. Okay, next we are going to see evaluation matrices. Okay, evaluation matrices. Now you may wonder, how do we know whether our regression model is actually good? That's where evaluation matrices help us. Let's imagine something, guys. Suppose the actual house price is 50 lakhs. Okay, our model predicts 49 lakhs. That's a very small error only. Now imagine another prediction. Actual price is 50 lakhs. The model predicts 90 lakhs. That's a huge error. Why? Because means the evaluation matrices, it will be simply going to measure how far our predictions are from the actual values. The most common matrices are MAE, MSE, RMSE, and then R square score. You don't have to memorize the formulas right now. Okay, just remember one simple rule: lower error values are always better. And for R square score, it is closer to the 1, the better the model. Okay, see that 4 matrices value. MAE is nothing but mean absolute error, average size of error, that is it will going to ignoring the directions, and MSE is nothing but mean square error. We already studied in our schooling, right? It will be used to consolidate large errors more heavily, right? RMSE means root mean squared error. It will be unpredictable in the original units. It will be making a square. R square means coefficient of determination. That means it measures how well the model is able to fit the data. Okay, so the R square will be closer to 1. Also, it will be better model fit. Or R square is the widely used better model, better evaluation matrices. Okay, next we are going to see the comparison of regression algorithm, how it will be comparing. So when should we use each regression algorithm? Guys, if the relationship is simple and straight, means linear regression works very perfectly. Okay, if the multiple factors affect the output, means multiple linear regression is the better choice. And if the relationship is curved, or else if the relationship is more complex to handle, means polynomial regression becomes the right option. And then choosing the right algorithm always depends on the data. I already said poor data will always gives you a poor prediction. A good data will always give you a better results. Okay, see the relationship, it will be a straight line, and then this one is a curved line. Input variables will be 1, multiple, and then 1 or more input value is acceptable by the polynomial regression. Complexity, linear regression is not more complex. It will be like a straight line, no, so that this is not causing any problem. And then multiple linear, it will be a medium. So sometimes it will be causing error, sometimes most of the time it will not causing any error. In the polynomial regression only highly complexity. Why? Because means it will be having one problem. That one is a overfitting problem. When the straight line, it will be polynomial also going to build a straight line, but the data, the result will be more huge, so that only it will be providing a curved complex. The curved complex means like a overfitting issue is caused by the polynomial. Okay, and then best for simple trends, multi-factor problems, non-linear. Okay, risk was underfitting. Linear regression contains underfitting, and then multiple linear regression is multi collinearity. That is the issue that will be faced by the multiple regression. I already said that polynomial causes the overfitting concepts. Okay, so this is how the comparing the regression algorithms. Okay, so we will be coming to the end of this session. So today we learned regression is used to predict the numerical values. We explored 3 important regression algorithms, right? Linear, multiple linear regression, polynomial regression. regression, right? We also learned where they are used in the real life and how we measure their performance using the evaluation matrices. Okay, so thank you guys for watching this series. I hope this video helped you to understand regression algorithm in a very simple way. One thing you have to remember, classification is nothing but it will be predicting the categories. Regression is predicting the numbers. Okay, so this is one of the most concept in machine learning. So make sure you understand it well before moving to the advanced topics. I hope you understand all the concepts, and I hope you will be enjoy this session. Okay, so guys, thank you so much for watching this session, and I will see you in the next intermediate machine learning lesson. Okay, so keep learning and growing with Life Changes Academy. Happy learning. Thank you guys.